The status quo right now for Web3 analytics is go to Dune.com and spend 20, 30, 40 hours making a dashboard with SQL that is usually 600, 700, 800 lines long. With Substreams, we can get that down to about 5 minutes. And not only that, it's real time. Dune, 2-hour delay window, Substreams, unfinalized block. We are Spyglass, and we are launching in a week, and we're excited to show you what we built so far. My name is Jordan Rain. I am a co-founder of Spyglass. I have a background in product and design for the past 10 years. I'm working in the startup field and Web3 most recently. And this is my co-founder, Alexander Gusev.
Hello. My name is Alexander Gusev. Every other analytic product in the space is garbage. No, not actually, but a lot of them leave a lot to be desired. A lot of the indexing technology really is not great, doesn't promote any sort of coordination or collaboration. And so I think that Substreams changes this, and our product is the easiest way to use Substreams.
Well said. I'm going to stop sharing for a little bit. Keep talking between ourselves. To elaborate on that, really what you see right now in the analytics field in the Web3 space is configurability or real time. There is this kind of gap in the middle where you can get real-time streaming and total configurability. And really, Substreams is the best technology for us to do that. We evaluated quite a few solutions, and we kept coming back here. Anything else to add on to that, Goose?
I don't think so. I think you hit the nail right on the head.
Beautiful. And I guess there's always the story of what to do with analytics, what actions you can take and what insights you can gain. And the beautiful thing that we would like to develop is Substreams allow the concept of syncs, kind of take the output of a substream from the blockchain, transform your data, and then would you like to save it to a Postgres database? Would you like to trigger a Discord notification? Would you like to emit a webhook? And so this kind of end-to-end story of do interesting transformations with the blockchain data and then actually take meaningful actions on top of that transformed data, that's what Spyglass is trying to tackle. Alexander, tell me, what's your Web3 story? How'd you get going in this field?
Well, my first introduction to any of this was Silk Road closing down, and all of a sudden my world was opened up to this idea of sending money online through the internet using something called the blockchain. And me being a little scheming 13-year-old thought it was really cool, and then I could make money by crunching math equations in my garage. And so I tried to convince my parents to let me mine Bitcoin in the garage, to which they responded, no, that's only used for drug dealers and terrorists. And, from that point on, I was hooked, so then I fast forward to about 2020, late 2019, I started getting interested in Ethereum because I realized I was okay, this is a really interesting computing paradigm that we can have verifiable code, which can execute and do things with other assets, which are held on chain. And so I thought this was super interesting. So I started diving in super deep, became a degen for a while and buying all sorts of random stuff and just playing around with everything that the Ethereum ecosystem has to offer. And then it was from there that I realized that there's a lot of work to be done and that I wanted to start building and playing around with stuff in the space. And so then I just started rapid prototyping and building stuff in my free time, which inevitably led me to dropping out of college to try and solve data analytics and, similar sorts of problems. So, yeah.
I love that answer. And I love that I have about 8 years of lifespan on you, but I think you have 5 more years of blockchain experience than me. And I'm curious, what's the story of blockchain analytics? When in, 2013, 2019, 2020, what were people using to kind of explore on-chain data?
I mean, 2013 was before my time. So I think there was .com or blockchain.com or something had some really rudimentary Bitcoin block explorer you could use to get balances and transactions, because those are kind of all you cared about at that time. But then, lately people have they're rolling their own infra, kind of I guess 2019, 2020 was a lot of Etherscan, kind of CoinGecko, these similar sorts of sites that are centralized and they have their own infrastructure. And so they're just querying their own nodes for specific data. Then I guess we also had stuff like the Graph as well. But when I was first getting started, I didn't really know what that was, but it seemed like kind of the two options where you had people building their own subgraphs using the Graph, or they were running their own centralized infrastructure, or using something like Alchemy or Infura, they have like their own centralized endpoints that make it easier to like get specific information regarding NFTs or ERC20s or stuff like that. But it was kind of like, yeah, those are kind of like the main options, I think.
Mm-hmm. So you had the centralized solution, the decentralized solution. Subgraphs were a game changer, like you actually had the ability to kind of like craft your own API on top of the blockchain. But tell us what you liked about it and tell me what you did not like about subgraphs.
Yeah, well, what I liked about subgraphs was the actual usage of them. GraphQL is great to work with. It's super easy. You just kind of write a declarative statement that says what data you want, and then it fetches it for you. It's like kind of like what isn't there to really like about it, I suppose. But the flip side of that is the process of creating a subgraph can be very, very painful. Everything, like all of the mappings over the original blockchain data, is written in AssemblyScript, which is a half-baked and unfinished language, respectfully. It's a great language, props to the people that are building it, but it's just unfinished for what it's trying to be, which is TypeScript that compiles to WebAssembly. And so as a result, it always felt like we were fighting the compiler or fighting various sorts of issues, or you would get into a flow and start writing your TypeScript, and that's like, oh, hey, that language feature isn't implemented yet. Start deleting code to figure out what broke, which is a real error that you'll get in some cases. And overall, the whole experience is just painful and they're slow, so you kind of can't do everything you would want to do. But that all changed recently with the whole Substreams powered subgraphs becoming live on the decentralized network and hosted service. So, yeah.
So clarify for me, what's the evolution between subgraphs to substreams? What changed and what stayed the same?
I guess, practically speaking, a lot of things changed. I don't really know how to even answer that question, frankly. What changed, what stayed the same was you could still use GraphQL to query your blockchain data. It was still possible to get your substreams to sync into subgraphs. And so your user experience could stay the same to the developer who was actually building with the data that you were working with. However, the main difference was kind of that the process there is much more sane, and it's also way more performant and much easier to debug because of kind of how substreams are architected. It makes it very nice to work with. So.
Well said. And just to kind of give some clarity on Spyglass, we were originally called Soulbound. We launched in 2021 during the bull run, and we had the dream of building a no-code subgraph editor. We quickly discovered that this is a much trickier problem than you might imagine because A, subgraphs aren't composable. You can't say I have subgraph A, I want to take some functionality from subgraph B and easily glue that together. Can't happen easily. And B, subgraphs aren't real time in the sense that it takes multiple minutes to compile, deploy, and sync a new subgraph. And so I was kind of digging into Dune for having a 2-hour delay window with their SQL view and analytics dashboards, but subgraphs weren't much better. So even though we built a really cool decentralized technology, if it can't match a centralized alternative, it's not going to succeed. This kind of changed with the, with the introduction of substreams. We kind of discovered that, we can build no-code analytics tools, and the developer experience is leagues better. And not only that, things are modular. I can take substream A, and if substream B has the same protobuf, and start gluing modules together. And so enter Spyglass. We discovered that we were infringing on another trademark. Someone else quickly trademarked Soulbound, and we pivoted to Spyglass, which is an equally cool name, and we can keep the same S logo. And then we've been heads down hacking for the past 6 months. And so without further ado, I'd like to give a quick demo of what we built.
Well then, Jordan, let's hear about your Web3 journey and how you got into this crazy, crazy space.
I was roommates with the infamous Jackson Blazinski. He was the original cryptographer at The Graph, and we were both CS students. And every day after class, he would start ranting at me that Bitcoin was the future. And it was one one of those Jehovah's Witnesses, with the pamphlets. He would give me white papers to read and articles to explore. And I'm no, dude, this is nonsense, man. I'm a JavaScript guy. Let me build some pretty styling and some CSS. But, he's a stubborn and persistent man, to his credit. And by about 2018, 2019, I actually started investing in crypto. That was when forget which tokens I had a little portfolio of, but it showed me that the fundamental problems of crypto were extremely technically interesting, and there was financial gain to be had by those who could play the game best. So around 2021, I went from selling cannabis at scale at iHeartJane to selling block analytics at scale with Soulbound. We had the idea that, analytics are extremely difficult. Like the status quo is Doom 600 lines of SQL, Etherscan, just like transaction logs, no context. Not only user unfriendly, but user hostile in certain cases. So we dove head in. It was the bull run. So there was this kind of euphoria of like, let's build. And I wish we had waited a little bit longer for Substreams to be released. We did not. And we built some cool stuff though. And now with that Substreams are on the table, we are excited to be launching in about a week. And folks can actually kind of like visualize the power of Substreams, and they don't have to hear me talking about it. They can see it in real time.
Nice. Yeah. What's kind of been the experience working with Substreams versus Subgraphs when it comes to the stuff that you're working on?
Yes, I'm a product guy, and the entire challenge is how do we make the esoteric concepts of blockchain simple enough and digestible enough for like the everyday technical user to understand. Substreams, even though they're written in Rust, which is a scary language to some, and the types are strange, the architecture is very sound. Like the four concepts you have to understand are maps, stores, params, and sources. That's it. Like if you can get that, at least you have like a foothold into Substream land. And how that works is that sources are your blocks. That's like an Ethereum block or a Near block or a Solana block, just transaction level data. Those feed into maps usually, which kind of do this like transformation, this filtering, this extraction. They kind of grab the interesting data, enter stores, which you can kind of use as a source of state to like aggregate data, computed values. And then params also come in to modify. Say you have a Ethereum scanner Substream. Params let you say, I want to track this contract. I want to track this contract. I want to track this contract. And so all this is a little node diagram. The fancy term is directed acyclic graph. And the output is just a map module that goes to your terminal, that goes to your browser, that goes to your database, that triggers a webhook, triggers a Discord notification, that triggers a DeFi investment, whatever the heck you want. That's the mental model. It is wonderfully simple and refreshing from a designer's perspective to kind of express that, where with subgraphs, there's a bit more of a story of it's like graph node here and deployed over there to the hosted service, which is now the studio, the decentralized network. There's a little bit more cognitive load to, I think, understand that process, where here it's just extract, transform, load, action. That's it. No magic. And it's like all code that I feel at a high level anyone can understand. So that's what excites me from a Substream designer perspective. You can kind of explain it pretty quickly.
Nice. Yeah, I agree with a lot of those. I think Substreams are much simpler conceptually to understand than any of the other data indexing technology, because I think that people can very quickly grok what's going on by just applying pure functions to blockchain data and aggregating values in stores, and then working with some outputted protobufs, which very cleanly maps over from the initial source material. So yeah, I think I definitely agree with all those points.
Just a new word, protobuf. Could you explain that to the audience?
Yeah, so protobufs were initially built by Google, and basically what they are is they are a language agnostic way to serialize data. What does that mean, realistically speaking? It's just a language agnostic, meaning it can be used in any language. So there's protobuf implementations in Python or JavaScript or Rust or probably other languages. I don't know, liking on some of them. But they are just a way to work with structured data. So things such as like objects or dictionaries in Python and JavaScript, these are structured sorts of data where you have key value pairs, and these keys are going to be of a particular type, and the values are going to be of a particular type, and they're structured in some way. And so protobufs are just a way to allow different services to talk to each other and use each other's data, even if they're written in different languages, but to be able to still interact with them all the same. So you can kind of think about it as a way for programming languages to very easily talk with each other without knowing what exactly they're talking to. So
well said. And I guess like Spyglass, one mental model to have when dealing with our new application is to think of it as a visual layer to manipulate the maps, stores, params, sources, and protobufs, to visualize it, to orchestrate it, to glue it together, and to output to meaningful action. So we are the kind of GUI built on top of Substreams, which is amazing technology, kind of make the whole process a little bit more streamlined, especially for non-technical folk or non-Rust developers. It's a gateway where you can go that direction, do a deep dive, but you don't need to. Any data you want to get, any way you want to visualize it, that's still accessible to you.
Which I think is that's a really important piece to mention, is that it's just supposed to be accessible and simple. It shouldn't be so hard to get the data you care about. You should be able to, put together these puzzle pieces, these beta Legos, if you want to be able to get what you care about. So,
and that, I would say, is the fundamental problem with Web3 in general. Getting the data you care about way, way harder than you ever think possible. It's not built for user friendliness. It's built for crypto degens who are reading arcane textbooks and extracting binary data from transaction logs. And for us mere mortals, we need a chart, and I think maybe they do too to make their decisions. Welcome to a quick preview of what we're launching in 1 week. Spyglass, delightfully simple Web3 analytics made for future builders. Instant, accurate visuals and analyses for DeFi, DAOs, NFTs, and more. Real-time streaming from 10 plus blockchains to your browser, database, or CLI terminal. Want to see what's possible? Explore the substreams below. So here we have some featured substreams that, because this is localhost port 3000, I have decided to highlight. And down here we have a table, kind of a similar view because there's only 4 substreams in the system, of what's been uploaded. So substreams, the particular file format is a S package, and in each S package, you can kind of extract those ingredients we were talking about earlier. So if you hover over here, you see we have 2 source modules, sfethereum.type.v2.block and sf.substreams.v1.clock, 0 params, 18 store modules, format modules, 1 visualization. Let's take you through the process, how it looks like to upload a new substream. So here we have some wonderful Midjourney images. You can kind of click around until you find something that looks pretty cool. I like a little bit of, that's pretty cool, little block data. Let's say I have a Uniswap V3 built, and I'm going to say V3 pools and transactions. You're welcome to provide the GitHub URL if you want to do a good deed. And let's select my Uniswap V3S package, wait for it to load, and you get a preview of the structure and content of the substream. I click Upload Substream, give that a second, wonderful. Right now, it's a blank canvas on the visualization page because no one has built any visualizations. But if you want to see the data flow diagram, this is how a substream works conceptually. You have blocks and clocks. Those are the sources. They rhyme. Wonderful. 19 stores to kind of take a look at. Honestly, the most important modules that you need to pay attention to are map modules. These are the modules that serve as outputs as a substream. So we have map pools created, map tokens whitelist pools, map extract data types, and graph out. And you are welcome to say, I'm curious about map pools created. Click the ellipses. You can either click visualize, go to the CLI guide, or explore the buff definition. This is the kind of data structure that gets emitted from this particular map module. And so you're like, oh, this looks pretty interesting. I'd like to visualize that. Let's go back to visualize, click new visualization, give that a second, and we're on map pools created. And wow, it's already loading the data. Let's make another visualization for it. Okay. And make another visualization. Okay, cool. And so here is our kind of canvas for taking a particular map module. And right now, this is just a data table, not too fancy. And you see that kind of protobuf definition right here is represented in tabular form. Address, created at timestamp, created at block number, address, name, decimals, interesting stuff. But right now, you go to Etherscan and kind of get similar tabular information. I think it'd be much more interesting to click the configure option here, and maybe you care about a heat map, and you can group by, you can do a little drag and drop magic here, pool 0 address, and you get a different visualization of this. And because I am just speedrunning this, it doesn't quite make sense. Let me try to get something better here with a sunburst. And now this is all of the group by created pool 0 address. And perhaps I would care about the total sum of the V tiers to determine the size of that. Nice. So you can kind of hover over and see what it looks like for each pool and the total sum of the fee tiers on that pool. This is a bit of a contrived example just for the speed run, but the point I want to get across is that you have unlimited views here to kind of like construct your canvas. Any visualization that matters, you can choose here. OHLC, candlestick, Y scatter, Y area, Y line, Y bar, XY scatter, OHLC. Even though it takes, we've got this down from 40 hours to 5 minutes, it still takes 5 minutes. For the sake of the demo, I leave the exercise up to the reader to actually create these wonderful visualizations. Or what you can do is say, community visualization, give this a name, visualization, and click save. And if we go back to Uniswap v3, visualization updated, good job, here's a cookie. You get to see exactly what we just built, and other users can explore and modify. And that's the kind of story here where folks can upload their substreams, and they don't do this for their own goodness of the heart. They do this so other users can actually visualize that data and share that visualizations with them. So it's a collaborative effort to kind of like unpack the underlying blockchain data, explore it, visualize it, and share it with the community. And this is just view one. We will get submission, the kind of like likes, shares, and like forks coming soon, but we move quick. So shipping that out pretty soon. And the final story I would like to tell is that if you go to CLI Guide, this is a work in progress page, but we're not like gating any substream here behind a credit card or a token. Share it, and anyone can install the substream CLI, retrieve an API token through StreamFast or Pinax, and then run the substreams command locally to stream this data directly. If that substream has a Postgres sync or a potential graph out module, you could sync it to your database, sync it to a subgraph, and that is also something we'd like to instrument from the front end. And I guess the story of where we're going is right now we expect people to upload substreams with the pitch that you will get amazing visualizations on your substream package. The goal that we are shooting for by the end of the year is for folks to be able to compose substreams within the interface and not touch a line of Rust unless they want to. That's where we're going, no code editor for substreams. And so we're excited to be launching in 1 week, and we'd love feedback and for folks to give this a go. Download, upload, explore, CLI stream, all those action verbs I just mentioned, you can try out 1 week. Thank you. Why not subgraphs? Why did it take so long for us to make Spyglass?
Yeah, well, there's a really important piece here with substreams, and it's alluded to in the name of substreams, which is that is a streaming first data platform. And so what that means is this data is streamed into you, not in one request, but in a bunch of chunks within a single request that you're making. So you're opening up a connection to the Firehose endpoint, and it's gradually streaming in data across each block that it comes across. And so there's a really important piece here, which is that why not, when asked the question, why not subgraphs, why substreams? Subgraphs don't have the same property, and you kind of can't really do this with subgraphs. Not, at least let's put it this way, you can't do this nearly as simply and as easily as you can with substreams. Substreams allow us to add custom params when we actually go to request our data. So if I create a generalized NFT parsing module, which tracks data, which is actually something that we did build for our site, it tracks trading data on Blur and OpenSea, I can just pass in a single string, which represents the contract address, and the substream will immediately start sending me data corresponding to this particular contract address that I posted in. And so if we try and compare this to how things would have looked at when we were doing things with subgraphs, we would have had to update the code to include this new address, recompile the entire subgraph, deploy it to the network, and wait for the subgraph to start syncing. And only then will it start syncing at the initial block, and it would take a very long time. It would be a super clunky user experience. Here, we can customize all of this kind of as we're wanting to fetch our data. So we can, specify exactly what kind of data we care about, when, in terms of like historically, when we want to start streaming that. Do we want to start streaming it at the latest available block? Or maybe we want to stream it from a week ago. We can customize all these. And so as a result, the general user experience with Substreams is really, really good. And so it enables us to build the best platform that we can possibly build. It is also worth noting that Substreams and Subgraphs are two different products, because Subgraphs are also powered by Substreams, or at least they can be. And so one of them is an easy-to-use GraphQL API, and the other one is an extremely high-performance dump of data. And so, yeah, they're just different. They're not necessarily comparable in that sense, but for what we're building, they are comparable because Substreams give us a much more tangible and rich experience when it comes to actually digesting and processing that data.
Substreams are ridiculously fast data streaming solution, and you don't have to depend on Alchemy centralized server or Dune centralized server or what have you centralized server. You could build it and run it locally. That's amazing. I think that the composability story, the modularity story, and the customizability story of Substreams is unmatched. You are not limited by the language. You are not limited by speed. You are not limited by output. It has first-class support for everything that I just mentioned. I've never felt bottlenecked by the technology. We have thrown every contract in existence at a Substream and indexed it. We have thrown damn near every NFT at a Substream. It indexed it. We have thrown tens of millions of rows at a Substream. It can process and index and output to our Postgres database. I challenge the listener, try to crash your Substream. It is very challenging to do so. There's a lot of foot guns and gotchas and other solutions. There's a lot of limitations about what data you can actually transform. Substreams, those limitations and challenges are few and far between and damn near none. So 2 thumbs up for Substreams. We are happy builders and sharers of the Substream gospel, and we are excited to be launching a Substream-powered product in 1 week. Thank you very much.